All right. So connecting to, setting up a network. So the first thing we need to talk about is communications on a network. And obviously there are no communications if we don't follow the set of rules. And these are called protocols. And for networking, for the internet, for the most part, what we use are some protocols called TCP/IP. And that's what we'll talk about tonight. So what you'll have is basically the computers have to be able to find each other. Then they have to agree on what methods or rules they're going to use to talk. And then they make requests from one computer to the other. They answer, they go between. And most of what we do, we talked about before, is done in a client-server type model. So here's a good example of their client-server model. Here's you sitting at the computer. Here's the interwebs. Here's a web server out there somewhere. Layers of communication, they involve hardware, the operating system, the applications, and then they see how the computers are addressed, how they're found on the network. To start with, as I said, we use TCP/IP, Transmission Control Protocol, Internet Protocol. So before data gets onto a network, it's first broken up into some segments. Each data segment is put into what's called a packet. The packet will contain a payload. That's information that you want to send at the beginning there. It's called the IP header, and it will identify what type of data that you're sending. It will identify where it came from and where it's going. If it's a lot of data, it's going to be divided into several packets. Communication is actually going to happen in layers. And as we go through this, I want you to understand that when we're talking about, and I'll just throw some terms out there, but when we're talking about communication on the network layer or transport layer or the session layer, all those are taking place at the same time. It's not like one happens, and then another. All of them are taking place at the same time. So, for example, here at HTTP, this is a protocol used by browser, your web server. Everybody's probably familiar with that. And here you see a person connecting at that layer with the web server. The operating system. And finally, down at the hardware layer, got your network card talking to the hardware layer of a server somewhere. So let's start down there. Your network card, your network interface card, is the first part of the physical network that we're going to talk about. Every adapter has a 48-bit number hard-coded on the card by the manufacturer. This is called your MAC address. Everybody should be familiar by now with the MAC address. Media access control. Part of the MAC address identifies the manufacturer that is responsible for making sure that no two network adapters have the same MAC address. And the MAC addresses are used for a computer to locate another one on a local area connection. So if you're on a LAN and you're not going outside of switch, the MAC address is the only thing that's going to be used, because the switch itself will keep a MAC table, and it will be able to tell if that MAC address is on that switch or not. If it's routed traffic, if it has to go beyond that, then you will need an IP address. A router is a device that manages traffic between two or more networks, and it can help find the best path for traffic to get from one network to another. I'm going to use this term a lot. A gateway is any device or computer that network traffic can use to leave one network and go to a different network. So, for example, let's see. At home, you've just got a box. Right, and you call it your modem, you call it your router, you call it whatever. All of that's correct, but it's also your gateway. It's your internet gateway. At work, you're going to have a router come in with a port, and it's going to go to however many switches or other routers it goes to, and this is going to be your outward-facing router. It's going to be your gateway to the internet. So that's essentially what we're talking about when we say gateway. And when you're setting up an address, or when you're setting up a network, you will need to know the gateway address. That's one of the things that you'll need to fill in, is tell it, hey, this is where you go if you need to get out into the Wild West. The operating system level, it uses IP addresses to find other computers on your network. So an IP address is a 32-bit or 128-bit string that is assigned to a network connection when that connection is first made. A MAC address is used only to find a computer on a local network. An IP address is used to find a computer anywhere on the internet or on an intranet. And an intranet is just any private network that uses TCP/IP. So when several local networks are tied together in a subsystem of the larger intranet, this group of small local networks is called a subnetwork or subnet. So you are a company and you have subnets for lots of different things, financial activity, or you have a subnet for warehousing, inventory, that kind of thing. You have an IP address, one overarching enterprise type address. You have lots of subnets under there that may be divisionally split up into different areas of your company. And there are going to be addressed IP addresses inside of that. And we'll get into subnet in a bit. The application level, basically what we're talking about is each client server application that's installed on a computer will be listening, sort of active at a pre-ordered address number, so a different port. So for example, we're all familiar with the internet, and when you're talking about the internet, you're talking about port 80, period. That is the convention. So port 80 is always going to be listening for internet traffic. So if a client sends a request to 136.60.30.5, port 25, that's going to be the email server. On the other hand, if it sends it to the same address, port 80, that's going to be the web servers. Okay? So here's your business address, 136.60.30.5. And then if you send a packet to 136.60.30.5, port 80, that would get the attention of the internet, the web server. And here's a little graphic to show that. Delivery man has a delivery from port 80. The nice lady here says, I'm port 80, I'll take it. And here's an idea of how it moves. So you see this guy represents the browser. This represents the operating system, which is not so subtly Windows. And then this represents the NIC. And then you go through the network, back to the NIC of the computer that you're arriving at, through the OS and to the web server. And this web server, or this OS, would exist on this web server. Again, not so subtly Windows. How IP addresses get assigned, whereas a MAC address is embedded at the factory, it's not going to change, right? Your MAC address is your MAC address. An IP address is assigned. So you can do a couple of things. You can do dynamic IP addressing, which is just what it sounds like. It's changeable. Or you can do static IP addressing, where, again, just what it sounds like. It's not changing. I know this is not going to change, so I'm just going to call it this. Now, there are a couple of things you might do with that. For example, before we talked about the your gateway address. That's not going to change. That's a static address. It can't change, right? And if you are a company and your front door to your company is 10.3.3.2, that can't ever change, because when people put in yourcompany.com, it needs to resolve to that address, right? So those addresses are always going to be static. But subnets, the things you do inside your company, you can change those. They don't matter as much. The only problem is, of course, keeping track of the changes. So for dynamic addresses, and the way you keep track of it is using DHCP, a dynamic host configuration protocol. If you've got that configured on a server, it will give IP addresses to a computer when it first attempts to initiate a connection to the network. If you request a IP address from a DHCP server, you are the DHCP client. They call it leasing an IP address. The good thing about that, you don't have to keep track of it. The DHCP server keeps track of it for you. And you can release IP addresses, because you will sometimes have problems with computers resolving web pages, that kind of thing, due to IP addresses. And you can release and renew a new lease on a IP address. So as we said before, your IP address has 32 bits or 128 bits. When the internet and TCP/IP were first invented, it seems that 32 bits were more than enough to satisfy the needs. And that standard IPv4 was created with about 4 billion potential IP addresses. Today, obviously, we need many more than 4 billion IP addresses. Partly because of that, IPv6 was created, and it uses a 128-bit address. Currently, we use a mix of 32-bit and 128-bit IP addresses. We'll start with IPv4. People get a little intimidated by IPv6. I'm not sure why, but once you get to know it, it's much easier to use. The Internet Assigned Numbers Authority is responsible for keeping track of assigned IP addresses and has already released all its available 32-bit IP addresses. IP addresses leased from IANA today are all 128-bit addresses, and you can go out and look at this place at IANA.org. I suggest you do so if you haven't. It's kind of interesting to see. And you should do a search, see who owns what. All right, so how are IPv4 addresses used? A 32-bit IP address is organized into 4 groups of 8 bits each, which are represented as 4 decimal numbers separated by periods, such as 72.56.105.12. So the largest possible 8-bit number is 1111111, right? Which is equal to 255. Now, let me stop there. Why is 11111111 equal to 255? Because of this, right? If I turn all, now remember, we're talking in binary, right? So everything's either on or off, okay? So metaphorically speaking, if I turn all of these on, 1, 1, 1, 1, 1, 1, 1, 1. You add all that up, 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. That's 255. Okay. So if you had an IP address of 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. This IP address would be 255.255.255.255. Okay. Does that make sense to everybody? All right. So just very quickly, having said that, tell me what this IP address is. What's that last? The last two are all zeros.
1.1.0.0.
Right. Now this isn't This isn't one you could use, but I just want you to get an idea on. Okay, so if we got that, does everybody understand how he got that? Okay. Let's say. That's teaching at the best right there. All right. What's that? That's right. 128.64. So you got it. You got this. Right? So anytime you want to break down an address, for example, if I wanted to say 72 in this would be off, this would be on, off, off, on, off, off, off. Right? So what I would have tipped is my 64 and my 8. Okay? Does everybody understand that? Good with that? That's all there is to it, folks. That's it. And anytime you need to do something, you can always, and I really, really encourage you to begin with, and we will learn networking or subnetting. I encourage you to do this, because once you break things down into its binary components, it really sometimes answers a lot of questions for you. It makes it a lot easier. But that's all there is to it. All right. There are some IP addresses that are reserved. Well, let's get to this in a second. So let's first talk about classful addressing. We have several different classes of addresses. Shouldn't be too hard to get through, but this is something that there's no good way to do it. You're just going to have to learn these. It's not difficult. Anyway, so for classes of addresses, from 1 to 126 is class A, 128 to 191, class B, and there are some. This is a very broad generalization. There are some exceptions in there. And class C, 192 to 223. If you look here, the one thing you will notice is, so for the class A addresses, the possible networks within class A addresses are pretty low, right? You don't have so many networks, but the total number of nodes that you can have in each network is enormous, right? So you may only have 126 networks that you can choose from. Of course, you can subnet all of those too. But for every one, you can have 16 million nodes, right? Whereas when you get down to class C addresses, there's this huge number of networks you can have. But you can just have a couple hundred nodes in each network, right? So it just depends on your needs, you know, how you set that up and what you need to do with it. So your first part of your IP address is going to identify the network that you're on, and the last part is going to identify the host itself. So in class A addresses, the first octet, each one of these is called an octet, okay? This first octet is going to identify your network in the class A address, and all of this identifies the node that you're on, okay? So everything that you see afterward, this may be 10 dot whatever, everything that you see afterward is talking about a host. In class B, your first 2 octets are your network, and in class C, the first 3 octets are your network, and the last one is your host. Any questions on that? All right. So if a company is assigned 87 for Class A licensure, then 87 is the network address. It is used as the first octet for every host using that license. So 87.001, 2, 3, so on and so forth. Now, as it says here, the reality is you're not going to probably use it that way. You're going to subnet this. But you could just do it that way, right? If you had 87, that was all yours, you could just use it all the way through. One of the big advantages of IPv6, right? Because you have so much, we'll get there, but you have so much space that it, you know, for most companies really, it actually could obviate the need for subnetting because you just have so many to choose from. But it's like, eh, whatever, just throw it out there. Now, obviously, you won't do that. For logical purposes, you'll subnet to keep things together. But so, the explanation that they give then, because 3 octets can be used for a Class A host address, one Class A license can have approximately 256 times 256 times 254 host addresses, which is a lot. That's about 16 million. So they arrived at that number. Class B license will lease the first 2 octets. They will be used for the host portion, the last 2, I mean for the network portion, and the last 2 will be used for the host portion. So in this example, the Class B license is 150.35. One of the addresses in there then, when a valid address in there could be 150.35.0.1. And by the way, we will get into things like, there are some things that you're going to have to keep in mind. If you've got this as your network address, then 150.35.0.0 is not going to be in the sign-up address, right? Because that's your network address. And there are even more rules that will apply there once we get into subnetting, because then you start getting into sizes of subnets, and you actually have to count up to the next subnet to make sure that you don't go past that number. So, all right. So Class C addresses, they are assigned the first 3 octets for their network address. Only 1 octet is used for the host address. Therefore, only 254 host addresses on a Class C network or its subnets. I said 255 before. 256 total possible. 255 is the largest number you can use because you use 0. So it's 0 through 255, right? Which equals 256. Everybody with me on that? This is changing, but I'm going to stick with the book here. Class D and Class E are generally not available for public use. They are used for experimental research, some multicasting. Some of those have been released, but generally speaking, you are not going to have access to Class D and Class E addresses. So, and you saw, by the way, you noticed that the addresses stopped at 223 rather than going on up through 40s and 50s, right? 30s, 40s, and 50s. And this is why. Those are reserved for Ds and Es. Okay? So you don't have access to those addresses. Some of the reserved IP addresses, 255, 255, 255, 255, that is a background broadcast message, and it will always be used for a broadcast message. 0.0.0.0. It says currently unassigned here. My take on that has always been that it's not actually addressing anything. Therefore, it doesn't make any sense. Kind of, yeah. And then, of course, home. 127.0.0.1 is always reserved for your loopback address. So that's a very basis of IPv4. Any questions on that? Now, why we do this, obviously, is and why we have to have name resolution and so on is because if I told you a sentence, well, I could sit here and tell once upon a midnight dreary while I pondered weak and weary. I don't know how many letters that is. It's a lot, right? And it's probably more than this, right? And I'm sure that if I quizzed you tomorrow, every one of you would remember that sentence, even if you didn't know the poem, because we can remember words, but we can't remember numbers as well. If I sat here and wrote down very quickly that same number of letters or numbers and said, remember these numbers until tomorrow, there's no way. Why? Why do you remember words so well, but not letters? What's the difference? Our numbers.
They have association behind them.
Precisely. Computers don't care. They're fine with this. People are. So that's why we have Sony.com, because we can remember Sony.com, and we can have the computer remember that. Okay. All right. So let's look at subnets. So they talk about a single class license might have millions of hosts. Managing a network with so many hosts is not practical unless you divide the network into subnets. Basically, to divide a network into subnets, you're going to designate a part of the host portion of the IP address as a subnet. Okay. So remember, the host portion is whatever. If you're in class A, it's some portion of those last 3 octets. Class B, last 2, class C, last octet. So, the example they give here is a class A license of 69. Without using subnets, you have one network, right? The first octet of all the IP addresses in this network is 69. The last 3 octets are used for host addresses, and the number of hosts in this one network is about 16 million. If you divide that one network into 256 subnets by using the second octet for the subnet addresses, in other words, subnets would be 69.0 through 69.255. Does that make sense? So now what you've got are the last 2 octets are used as host addresses in each one, with a potential of about 69,000 or 65,000 rather hosts in each subnet. So I'm getting some confused looks out there. So hang on. Now keep in mind, when we're subnetting, what we're talking about is this is totally an internal thing. Okay? In this example that they give us in the book, I'm given a network address of 69.0.0.0. Okay? This is what I'm given to work with. Now, one thing I could do is, this right here tells me I've got 16 million addresses I can play around with. But I need to subnet, right? I need to make logical structure out of my business, if nothing else. So what I'm going to do for myself and for my company, whatever my outside address or whatever my outward facing address is, for my subnetting in here, I'm going to say, you know what? I'm going to use these first 2 octets personally. Because I can do what I want with it. This is all mine, right? So I'm going to use these first 2 octets, and I'm going to make these, each one, a network address. So there's going to be a subnet here internally for me in my company called 69.1.0.0. And there's going to be a subnet called 69.2.0.0. And .3 and .4 and each one of those is a subnet. And on each one of those, I can use all of that space for hosts, for any nodes I want to put on there. Servers, printers, PCs, whatever I want. Does that make sense?
Defining the range that network.
That's exactly right. And that's just for me internally. It's just in my company. Right? When you're the systems administrator, when you're the network engineer, when you're whatever title it is that you've got, you and especially if you're starting up the business, this is for you to decide. You're going to break this down. Right? All right. The subnet mask used with IPv4 identifies which part of an IP address is the network portion and which part is the host portion. Okay, that's it. The network mask. It's just a number. That's all it is. Just a number. And all that number is telling you is which bit of this you're using for the network and which bit of this you're using for the host. Okay. All right. Using a subnet mask, a computer or other device can know if an IP address of another computer is on its network or on another network. So here we have this. Here we have a cartoon of a packet that is going to this particular IP address, all right? And it comes to a router, and it is basically saying, okay, well, here's where I'm going, and this guy says saying my IP address, subnet mask, tell me that the host is somewhere in my network. Wait here until we find it.
So creative.
Like all of IP addressing, a subnet mask is simply a string of ones followed by a string of zeros. That's the nature of binary. The ones in a subnet mask say, on our network, this part of an IP address is the network part, and the zeros say, on our network, this part is the host part. Okay. All right. If you don't divide a network into subnets, the default subnet mask is used, which is called a classful subnet mask because the network portion of the IP address aligns with the class license. And you can see that in descriptive form here. So this subnet mask, they don't actually list it out here, but you know how to count this now. This subnet mask for Class A, if you're doing classful subnetting, 255.0.0.0 is the mask, right? And that tells you, if you see 255.0.0, that tells you, oh, the only thing they're using is the first octet, 255. That's the network. Everything else is host, right? And Class B, same story. 255, 255. Boom, stop right there. That tells you, since that's where all the ones are, that tells you that those first two octets are the network address. All that stuff is host address. Same thing with Class C. 255.255.255.0. Okay. Yeah.
Let's say that my company's network exceeded the capacity for a Class C license.
Okay.
But we don't want to buy a Class B license because that's way too many hosts. Is there a way to purchase 2 Class C licenses and link them together?
And that's probably not what you would do. Yeah, the answer is yes, but that's probably not what you would do. Did you study VLSM when you were in?
I did not.
So that's probably what you would end up doing, which is beyond the purview of this class. But what you would probably end up doing is subnetting your subnets. So you would automatically create that many more subnets for you. The term I want to use, because everybody uses it, and you may or may not have heard this, is you're borrowing bits. Okay? You're not going to do classful subnetting. You're going to do classless subnetting, and I'll get onto that in just a second. Which gives you a little bit more freedom, but it's no more difficult to do. You just have to, when you get into that kind of thing, this really becomes more important, because another way of looking at, actually that's a very good point, another way of looking at this is if I say 255.255, another thing that I'm telling you is, look, on this IP address, as you binary it out, just when you start over here on the left, just start writing ones 16 times, right? Because those first 16 digits are all ones. And here, I'm telling you, just start writing ones 24 times. Right? 24 of the 32 times, it's going to be ones. So write 24 ones, 8 zeros, and you've got your subnet mask there, okay? That becomes important in classless addressing, because you will see things like addresses written out. For example, if it were written out that way, what is that? 89.100.13.78. I could tell you without writing out the subnet mask, without writing out 255.0.0.0. Another thing that I could do is just say, you know, I could write it out like that, right? And basically, I'm telling you this is a 255.0.0.0 address, right? Because this is called CIDR notation. And by telling you this, what I'm basically saying is write out 8 ones, and then the rest of them are zeros, which is basically saying 255.0.0. If I said that, what am I telling you?
The first 2 octets are all zeros.
All ones.
All ones.
Yeah, sorry. 255.255.0.0, right?
Same thing. It's class C.
Right.
All ones.
Right.
That's lost.
Look at this. It's fine. It's classless addressing now, right? We're stretching out. But I'm still saying the same thing to you. The first 26 spaces are all ones. You're going to use the first 26 spaces for your network. And then the last, 6 spaces are for your hosts. I'm still saying the same thing. And you can still just binary it out. You're just going to start over here and write 26 ones, and then 6 zeros after it. There's your IP, your subnet mask. Right? That's all CIDR addressing is. It just makes it easier to write. So you don't have to write all that out. Just write it like this. You know what your address is, and you know what your subnet mask is. Make any sense? We will come back to that. Let's go ahead and take a 10-minute break, and we'll come back.